Hi everybody, I hope all of you are doing great. So in today's lecture, we are going to see the follow-up problem of longest decreasing subsequence. The problem is very famous. It is like asked a lot in interviews. Like you can see in the company tags as well. So famous companies are asking this question. And the name of the problem is longest Bitonic subsequence, right? Let us read the problem. Given an array of positive integers, all of those integers are positives. Find the maximum length of Bitonic subsequence. Directly they are asking the question, find the maximum length of Bitonic subsequence. Let's see what is a Bitonic subsequence. A subsequence of an array is called Bitonic if it is first strictly increasing and then strictly decreasing. Okay. So bitonic, right? It's first strictly increasing and then strictly decreasing. Let us analyze this on board with a good test case and then understand the problem itself. So this is the test case I've taken here, which will beautifully demonstrate what is a bitonic subsequence, right? So let us look at the subsequence, right? I hope you understand what is a subsequence in an array, right? If I select some elements, let's say 9, I select 4, I select 12, I select 10. I've selected these elements, right? Let's select 6 as well, right? So I've selected these elements and you can see these all elements are belonging to this particular array. And since these elements are belonging to this array, and these elements you can see, right, they're in a proper order, although like some of them are not contiguous, right? 9 and 4 are not adjacent to each other, whereas 4 and 12 are, right? They are not adjacent, they are not contiguous to each other. They are, having some, like they can have some people in between, but still they are belonging to the whole array and they are in a proper order. This is a subsequence, right? This is the definition of a subsequence, right? Let us see what is the longest bitonic. Let's first understand what is a bitonic subsequence, right? So any subsequence which is first increasing and then decreasing is a bitonic subsequence, right? So let's say 1 2 3 4 3 2 1. If you look at this, here it is increasing 1 2 3 4, and then 3 2 1, it is decreasing. It is a bitonic subsequence. This is what a bitonic subsequence is, right? So I hope the definition of bitonic subsequence is clear. Let's see what is the bitonic and longest bitonic subsequence in this particular test case. So let us see, right? This 3, right? Let's look at some kind of subsequence, right? Let's select 1. Let us select 3. Can I select this 3? No, because bitonic subsequence is strictly increasing at first and then strictly decreasing. We cannot have equal people, right? So let's select this 4. Let's select this, let's say we'll select this 10. Okay. After this 10, let us select this 11 and then 9 and then 6 and then 2. Can you see this subsequence 1 3 4 10 11 9 6 2? It is first increasing and then it is suddenly what? It is suddenly decreasing, right? It is a bitonic subsequence. It is a bitonic subsequence, right? So I hope the question is clear to everybody that what do we mean by actually longest, like bitonic subsequence. This is of course the longest bitonic subsequence. You can see you have to return the length of the longest bitonic subsequence. The length is 1 2 3 4 5 6 7 8. So 8 is the length of the longest bitonic subsequence in this area, right? So I hope it is clear. So we'll be having some people who are increasing and then we are having some people who are decreasing, right? Of course, according to the question, we can have, some people who are increasing and we can have no people who is decreasing, right? Or at the same time, we can have like some less number of people who are increasing and then suddenly many people are decreasing, right? We can have this kind of subsequence as well. So this kind of subsequence where everybody is increasing first and then everybody is decreasing is called a bitonic subsequence, and in this particular test case this is the longest bitonic subsequence. I hope this point is clear to everybody, right? Let us see how we can approach this problem, and yeah, then move to the solution part of the video. To get an approach for this problem, can I think of a way in which I want some kind of a subsequence which is increasing first? We can get longest decreasing subsequence, right? We definitely know how to do that using LIS. We have already solved this, but this part of decreasing subsequence, can I say that it is kind of creating some problems, because now I not only want a subsequence which is increasing, I want some decreasing people as well after that, right? Okay, all right. So this left half part is clear when the people are increasing, but this part when people are decreasing is not clear, right? Let us try to resolve this part. Now think of LIS approach we did in tabulation, right? We have already discussed many approaches for LIS, right? Longest decreasing subsequence. Think of that approach, but in the reverse form of that array. Can you see that, if I consider this 2, 9, 11, 12, can you see that this is actually an increasing subsequence, right? If you look at this array from this you can say perspective, you can of course imagine 2, 9, 11 and 12 to be increasing. Yes or no? Correct. But if you look at the same from this perspective, they will appear to be decreasing. Is this clear? Are you able to get the intuition part of this problem? So if you in other words, what I'm trying to achieve, if I apply longest increasing subsequence on the reversed form of this array, right, I'll be having the decreasing part as well. Yes or no? Correct. This is the increasing part, right? This increasing part was clear, right? We simply apply longest increasing subsequence and that is the thing, right? Let's try to, get the longest increasing subsequence for every person, right? I'll try to apply the DP approach only, right? We'll look at the DP approach only and let us look at how we are going to apply LIS normally, right? Normal DP approach, we are going to apply LIS now, correct? So just have some patience. I'm going to apply longest increasing subsequence problem on this, right? Let's try to fill the tabulation approach, right? 3. If 3 is the last person of the longest decreasing subsequence, it is able to form a length of 1. If 1 is the last person, if 1 is the last person, how long can the longest subsequence be if we are looking at all these people? One cannot have anybody before itself. I'll write 1 here. I hope the longest subsequence part is clear to everybody. We have already discussed the approach of getting longest decreasing subsequence, what a longest decreasing subsequence is. You can of course check out my video on that, right? This is the playlist we are going through, so everything is interlinked, right? So please look at the videos we have already discussed as well. And let us now look at this longest increasing subsequence part of this problem. 9. If 9 acts as the last person of longest decreasing subsequence, people before it, there are 2 people before me, 3 and 1. I can select 1 is the best result. So 9, if 9 acts as the last person, it is able to form a longest decreasing subsequence of length 2. If 3 acts as the last person, can 3 select 1 to be the person to come before it? Yes, because I want increasing subsequence. If 1 stands behind 3, right, it is able to form of 1. So if 1 stands behind 3, and 3 is the last person, we'll add 1 here, correct? So here I'm going to write a 2 here, correct? 3. What's the best out of all the people who are smaller than me? 1. 1 plus 1. Like whatever this person is also standing, the length will become 2. The best of all the people behind me. It is able to find 2. So I'll simply write here a 3, right? Because 2 is 3 was able to form a longest in subsequence of length 2 with some people behind it. If 4 stands behind 3, the length of this longest subsequence will become 3, right? So what I'm trying to say, that whatever is smaller behind me, tell me what is the best of previous in the DP array. So 12, you can see all these people are smaller than 12, and 12 can essentially stand behind anybody. But can you see that 12 will want to stand behind this 4, because 4 is able to form a longest decreasing subsequence of length 3. Let's look at this. So 4 stood behind, let's say this 3. So 3, 4. 3 stood behind this, let's say this 1. Okay. And if 4 is the last person, it's able to form a longest decreasing subsequence of length 3. 12 wants to stand behind it. So can you see that 12 will be able to form a longest decreasing subsequence of 4? This 3 plus 1, 4. I hope it is clear that what the actual formula of longest decreasing subsequence is, right? So 10. All the people behind me, who is having the best result, those are smaller than me. 10 cannot stand behind 12 because 12 is bigger than 10. So this cannot be considered. This 4 cannot be considered. 10 will consider this 3, this 4, whatever this 4, and the DP array, in the DP array we are having a 3. So 10 will say I'll be able to make a form of length 4. 4, it is able to select this 3 because this is the smaller person out of all these smaller people. This 3 is having the best result, and this, whatever this result, this B is having plus 1 because I am standing as well. So I'll write here 3. 11 can choose this 10, right? 11 can choose this 12, this 10. So 11 will say I'll be able to make of length 5. 9 cannot choose this 11. It can choose this 4, cannot choose this. And you can see the best result is out of this 4 or this 4 only. Both are having the same result. 9 will be able to form of length 4. Correct. 6 will be able to form of what length? Let us analyze. So out of all the people before me, let's see. 6 wants to search for its own answer. 6 cannot stand behind 9, it cannot stand behind 11, it cannot stand behind 10, cannot stand behind 4. This 12, it cannot stand behind this 9 as well. And out of all these people, can you see this 4 is having the best result? So 6 will quietly say that yes, I'll be able to make a sum of 4 as well, because this 4 is having a 3, right? I can stand behind that 4 and I'll be able to make 3. 2, only one person is smaller than 2. It is having a sum of 1. So like length of 1, so I'll be able to form of length 2, right? I hope this is clear that if every person, this is what data. If the ith person, if this 4 acts as the last person of longest decreasing subsequence, what is the best length it can make out of that longest decreasing subsequence, right? Now, be a little bit patient. We have seen the left side of the thing, right? Bitonic. The question is for Bitonic subsequence, right? So we have handled this side. Now I'm going to apply the same algorithm for longest decreasing subsequence, but from the reverse order of the array, right? Let us look at this. Now we are going to see this same thing in the reverse order of this array. Now we two will say that if I want to form a longest decreasing subsequence, what is the best length I can make? We are looking at this thing now, right? Earlier we were looking on the left side of the things. Now we are considering the array in the reverse order. So 2 will say if I am the last person. If I am the last person, what is the best length I can make in the longest decreasing subsequence? I can say only 2, right? Only 2 we are able to make. 6. If 6 has as the last person. So who are the people smaller than 6? 2 is smaller than 6. What's the best it's able to do? It's able to make 1. So 6 will be able to make 2, forming 6 comma 2. Correct. 9. 9 will simply say what? I'll stand behind the 6. Right. And we are able to form what? Can I say 9, 6, 2? 9 is able to form this longest decreasing subsequence. I hope it is clear to everybody. Alright. Now let's talk about this 5. 5 wants to form a longest decreasing subsequence. You can see only let's talk about this 11, right? 11. 11 can stand behind 9 and it will be able to form a longest decreasing subsequence of what? Of length 4, right? Of course, I have to write 3 here. I don't know why I did this mistake. I have to write a 3 here, and here I'll be writing what? Here I'll be writing simply 11 is standing behind 9. So 11, 9, 6, 2. I hope it is clear that now we are trying to form a longest decreasing subsequence from this side of this array. You can see this is a longest decreasing subsequence. This is a subsequence. This is a subsequence, right? This is a subsequence, right? So in this particular array, we are considering left to right results. Here we are considering right to left. So increasing subsequence, but in the reverse form of that array. Essentially, it will be forming a decreasing subsequence. Like you can see here, right? 11, 9, 6, 2 is a decreasing subsequence we are forming here. So don't worry, let's continue. 4. 4 will be able to stand behind this 2. And 4 will be able to make a length of 2 because 2 is able to make 1. So 4 will stand behind 2. 10. It can stand essentially other than 11, it can stand behind 9 as well. So 10 will be forming a longest decreasing subsequence of length 4. Essentially saying 10, 9, 6, 2. Something like this, correct? So 12. 12 can stand behind anybody of them. It will of course want to stand behind this 11 or this 10. Both are having the same result. 12 will be able to form a length of 5. Let's continue. 4. 4 can stand essentially behind, it can only stand behind 2. Right, we want strictly increasing, right? So it can only stand behind this 2. So if we want to stand behind this 2, what can I say? If we are wanting to stand behind this 2, I am just saying that I'll be able to form a length of 2. 3 can stand behind this 2 as well. I'll be able to make a length of 2. 3 again can stand behind this 2. 9. It can stand behind what all people? It cannot stand behind this 10. It cannot stand behind this 11. 9 can stand on what else people? Now these two choices are not there. Of course, this 12 is also not there. So best I think, of course, like let's slow down for a little bit. This 9 will not be able to stand behind this 12. It will not be able to stand behind this 10. It will not be able to stand behind this 11. It will not be able to stand behind this 9 as well, right? So what else? What else? What other people are having the better result? So we are able to make a result of 2 only. So this 9 has no options but to like suffice with this 2 only, making a sum of 3 for itself. 1, it cannot stand behind anybody. It is only left with the choice of standing alone. 3 can stand essentially behind this 2 only, and because of this it will be only able to form of length 2, right? I hope this is clear. Till here I hope it is clear that in this particular array we were forming the longest decreasing subsequence from left to right. In this particular array we are forming the longest decreasing subsequence from right to left, and everybody here is acting as if I'm like, if we are considering the reversed array and I am the last person, right, of the longest decreasing subsequence, what is the best length I can make? Here everybody is deciding that, and here too, right? But the only thing is this array was made from going to left to right. This array was made from going from right to left. You can say this is the longest decreasing subsequence array. You can say DP array when the array is normal. This is when the array is reversed, correct? I hope these two construction parts of these things are clear. Now the question has become very simple. Let us dive deep into it. Okay, so can you see one thing? Let's look at this. Let's look at this. If I'm talking about this 3, when 3 acts as the longest decreasing subsequence in the left to right array, it is only able to form of length 1. When 3 is able to form of length 2, it is saying that I'll be standing behind this 2 in this particular array, 3 comma 2, right? So can I say that 3 is forming a Bitonic subsequence of something like this? Only if I disregard this 3, you can see it is forming of length always decreasing order only, right? I hope it is clear. Look at this, look at this. I'll of course explain it again very simply in very simple terms. Full focus, full focus. There you go. This array is let's talk about this index 12. 12 is saying I can, if I am the last person, I'll be able to make of length 4. Let's see what is 12 making. So 12 is essentially, let's say 12 is making this kind of thing. Let's say 1, 3, 4, 12. That's why I've written 4 here, because 12 is saying that the longest in subsequence which is ending at me is of length 4. This is what 12 is saying. Okay. All right. But on this index, 12 is saying what? 12 is saying what? If I am the first person, right, or you can say the last person from the longest in subsequence formed by going in the reverse order of this array, I am able to form of length 5. Let's see what is that length. So let's say 12 is standing behind this 10. Let's say 10 is standing behind this 9. And let's say 9 is standing behind this 6. 6 is standing behind this 2. Okay. So, alright. This is like, I think, okay. So 12 is saying that I am able to stand behind all these people, 9, 6 and 2. And you can see 12 is able to make this kind of subsequence, right? Now you have to look at the bigger picture of things. When 12 was standing behind all the people by going left to right, 12 is forming this kind of subsequence. When 12 is standing behind all the people from going right to left, 12 is forming this kind of increasing subsequence. Look at this closely. If I pick all these things up, I'll of course delete these arrows now. If I pick all these things up, if I overlap this 12 with this 12, can you see one thing? This subsequence is increasing and suddenly this subsequence is acting as decreasing. Is this clear to everybody? This subsequence is increasing because of this first half. This subsequence is decreasing because of the second half. Essentially, we are doing what? We are creating a Bitonic subsequence. I hope it is clear to everyone. So in simple terms, what the algorithm is looking like, you can see, right, if I can treat 12 as the center point, if 12 is the center point, from the left side it is able to make 4. From the right side, this 12 is able to make 5. And now you can see 12 is coming in this count as well, 12 is coming in this count as well. In the longest Bitonic subsequence, you see I overlap 12. This means that I'm only counting 12 once, so I'll decrease the ones. So what is the length of the Bitonic subsequence if 12 acts as the middle point? You can of course look at this by yourself, and it is making a length of 8, right? This is the length. 12, if 12 acts as the missed point, this is the best 12 can do, right? And this is how we are trying to solve the problem of longest Bitonic subsequence. We will try this out for everybody. So we can say 1 plus 2 minus 1 is the count, like is the best 3 can make if 3 is the middle point. Let's look at this 9. 2 plus 3 minus 1. 2 plus 3 minus 1 is the best 9 is able to make if 9 acts as the middle point, right? Let us look at some other middle point as well, just for the sake of explanation part. So 10, let's say if 10 acts as the middle point, you can see 4. This 4 means what? From the left side, if 10 acts as the last person, right, you can see 10 will, let's say 10 will stand behind this, let's say 10 will stand behind this 4, and this 4 will stand behind this, let's say this 3, and this 3 will stand behind this 1. This kind of subsequence 10 might be forming, right? There can be multiple subsequences of this length, but yes, this is just an example. If I'm talking about length 4 and 10 is the last person, this is the subsequence 10 is forming. If 10 acts as the last person from the right side of an increasing subsequence, you can see it is also making length 4. Let's say 10 is the last person, so it will stand behind this 9, and 9 will stand behind this 6, and then it 2, right? So you can see 4 from this side, 4 from this side, and if I overlap these two things, 10 is acting as the middle person, 10 is acting as the middle person, and it is making the longest, like you can say Bitonic subsequence of length 7. So for every index, after creating both of these two arrays, this left side, this right side, the same algorithm, the same kind of arrays, right? The same algorithm we are going to use that we use in the tabulation approach itself. You'll find the link in the I button itself. And what we are going to do here, we are basically pre-calculating both of these two arrays, and then for every index, this plus this minus 1 versus this plus this minus 1 versus this plus, of course here 4 plus 5 minus 1 I think would be like the best answer I could get. Or you can say 11 plus 5 plus 4 minus 1 will also come. If I treat 11 as the middle person, or if I treat 12 as the middle person, both will give somewhat the same answer itself. And I will take the maximum of all the equations, and in the end, whatever the sum is there, what is the maximum is there, that will be my longest Bitonic subsequence. Of course, 8 would be the answer in this case itself, right? So 4 plus 5, this for this particular index, 4 plus 5 minus 1, that would be the best answer. Or you can say 5 plus 4 minus 1, that would be the best answer, right? I hope the explanation part is clear. Let us quickly convert this into code itself. This series is linked, every video is linked to each other. So I really advise, if you're directly looking at this, right, I have discussed many tricks as well in these videos itself. I will be using those tricks in my videos. So I really advise you to watch the previous videos itself. And this whole DP series, I'm trying to make these problems in dynamic programming easier to understand, right? And at the same time, we are trying to make the things stick to our heads, right? So let us look at the coding part of the solution and then wind up this video. So here we are in the code editor itself, and first step I want is I'll extract nums.length. Let's extract the length of that array as nums.length. Then I will create an integer array L2R, or I can say DP underscore L2R is equal to new integer of length n. Let's create this array using the tabulation approach which we discussed. So for of course dp underscore L2R of 0 will be 1, because 0th index will be forming a length of 1 only, because if it acts as the last person, because there is no one before it. For the rest of the people, for I is equal to 1, I less than n, I plus plus, I'll take a variable called best of previous. Best of previous is equal to 0. And for all the people, j is equal to I minus 1, j greater than equal to 0, j minus minus. For all the people before me, best of previous is equal to math.max of best of previous, comma, dp of j. Correct. In the end, I'll be having whatever person, right? Of course, here I have to write a condition as well. If the nums of jth person is smaller than nums of ith person, then only I'll consider the dp of that particular, you can say the result of that particular number. Because only, no, if jth person is smaller than us, then only ith person can stand after this, na? So I'll consider this best of previous. Dp of I in the end will become best of previous plus 1. And this is how we have calculated the first array itself of LIS from L to R. I hope it is clear. We have already discussed this approach in the tabulation part of the longest decreasing subsequence. Let us quickly move forward and let us quickly make in another array integer dp R to L. R to L is equal to new integer n. Here you can say dp of R to L. Of course, here I have to, instead of writing this, I'll have to write this. Right, I'll be writing this R L to R, both of these two places. Here I'll be writing L to R. Here dp underscore R to L. Now this for this particular dp array we are creating from the last index. So R to L of n minus 1 will be 1. Now for integer I is equal to n minus 2, I greater than equal to 0, I minus minus. Same thing, integer best of previous is equal to 0. For integer j is equal to, now this particular loop is starting from the now we are going traveling in this direction. If you are standing from this person, if you are standing on this 5, we are going to look all the people after us. So j is equal to I plus 1, j less than n, j plus plus, and rest of the thing is exactly the same. If nums of j is smaller than nums of I, then only I will consider the dp information in R2L, of course, of that person. And in the end, I'll simply say dp of R2L of I is equal to best of previous plus 1. Right. And these are the two dp arrays I have calculated, and I have actually pre-calculated both of them. Right. Let us try to get the answer itself. So now I will consider all the indexes acting as the middle of the Bitonic subsequence. Correct. So integer answer, of course, I'll take initially 0. Right. For integer I is equal to 0, I less than n, I plus plus. Integer left is equal to dp of L to R of I. Integer right is equal to dp of R to L of I. Right. That's what we did. Right. That's what we did actually. You can see for this 12, I calculated this 4. This is the left, this is the right thing. Left plus right minus 1 is what I'm going to compare in the answer itself. So left, so answer is equal to, so you can say integer length, if I am middle is equal to, I can simply say left plus right minus 1, because ith person is calculated in left as well, it is calculated in right as well, so I have to decrease its single frequency, and answer will now be, we'll do a versus with answer comma len if I am mid, correct. In the end, I will simply return the answer itself, and that would be the whole code for this problem. I hope it is clear to everybody that what we are trying to achieve in this particular problem, we are traveling from left to right, we are traveling from right to left. This particular thing is the important part, because here if 12 is forming a longest degree, like increasing subsequence of length 5, this means that it is forming increasing subsequence like this, because we are creating from the end of the array. And if you look this particular kind of graph from this side, it will appear to be a decreasing. So you can see first we are calculating the increasing subsequence, then we are calculating the decreasing subsequence, and then we are calculating the result, and yes, it is passing the result, right? I hope this thing is clear to everybody. This question is clear to everybody. It's just an extension of longest degree subsequence. We have only done 2 times tabulation approach, which we did in the previous problems, right, of calculating the longest degree subsequence itself. I hope this problem is clear to everybody. Why did we do this? Of course, to consider every person as the middle index of the Bitonic subsequence. And I hope this problem is clear to everybody. If you are enjoying the content, please support the channel itself, and I hope you all are of course going through this journey with very smoothly, right? Your comments of course motivate me a lot, so keep on doing that comments and keep sharing these things with your friends, right? And yeah, until the next video drops, bye.